angles of elevation and depression. So this is the last trig lesson, typically. All right, and what it is just an angle of elevation and an angle of depression. The words kind of tell you how the angle looks. Okay, elevation. Do you think up or down when you think about an elevator? Typically, you're thinking up. When you hear that word depression, what are you thinking? Typically, you are thinking down. Okay, so angle of elevation or an angle of depression, you always look at the horizontal line. Always compare to the horizontal line. So, an angle of, let's start with the angle of elevation. Okay, it is from the horizontal line. Okay, from the horizontal line, opening up. So it's like from the horizontal arrow opening up. Angle of depression, draw a horizontal line, but this time it's opening down. Okay, so you always draw a horizontal going up, right? You're opening up an angle, and then horizontal opening down an angle. And we can see that here, okay? Here's one horizontal line, right? It has it kind of both in the same picture. Here's a horizontal line. That angle, since it's going from a horizontal down, is an angle of depression. Okay, again, to see that visual, right? Horizontal down. I'm going down from there. Okay, and then on this one, horizontal going up, opening up. Okay, so that's what's happening with the angles of elevation and depression. So, angle of depression, horizontal going down. Angle of elevation, horizontal going up. I really hope I said that correct. Let's just double check and say it again. Angle of elevation, horizontal going up. Angle of depression, horizontal, and then going down. Okay? So, kind of panicked that I didn't say the right one. Hopefully I did. All right? Anyways, first example. What you end up with on these types of problems typically is you end up with a lot of word problems. Okay? Now, I'll say the word problems most of the time are going to use sine, cosine, tangent, depending on the situation. All right? And it could be using just normal sine, cosine, tangent. It could be using sine inverse, cosine inverse, all those. It just depends. All right? But a lot of this lesson will involve word problems. So here we go. We've got to be able to draw the picture in order to get there. All right, so here we go. A wire needs to reach from the top of a building to a point on the ground. Okay, the building is 10 meters tall, and the angle of depression from the top of the building to the point on the ground is 22. How long should the wire be? So, let's draw a building first. Here's my building. I'm a pure artist, I tell you. Okay, the wire needs to reach from the top to the bottom. Boom. Now I see my triangle. Okay, from the top to the bottom. First of all, the building, how tall? 10 meters. Okay, I've got the building is 10 meters tall. Let's label my right triangle, okay, because we do have a right triangle formed now. Okay, so here's the hard part. Okay, this is where people will get confused. Okay, the angle of depression from the top of the building to the point on the ground is 22 degrees. Okay, 22 degrees. So everyone's like, oh yeah, the angle of depression, it's angled down. That is not my angle of depression, though. Okay, let me just go ahead and say that. Again, look at the definition, right? Look at the definition. You got to be very careful here. It goes from the horizontal going down. Okay, so from the horizontal going down, not just like in the triangle going down. Okay, so what you have to do, you actually have to draw your horizontal. That is your 22 degrees right there. Okay. That's your 22 degrees. All right, so a lot of people will get confused about that. They'll say, oh, yeah, the depression angle, got it. It's the angle that's going down. That's not the case, okay? It's the angle that goes from the, again, horizontal line, then going down. That's the angle of depression. Now, one thing you'll notice, though, about these is this line and this line are parallel. This is the line with the ground. This is the horizontal line of sight. If that angle is 22 degrees, that angle is actually going to be 22 degrees. Okay? So, and let me just go ahead and say this. That's actually your angle of elevation, right? Because it's from the horizontal up. So the angle of elevation and the corresponding angle of depression end up being the same. Okay, but again, got to be careful with that 22 degrees. It does not go inside the triangle on that particular one. Okay, so it's here. Again, definition of angle of depression starts from the horizontal. You can see my hand, it's horizontal, and I'm opening down. Okay? All right, so anyways, that's the 22 degrees. Okay? And I have that height of 10. How long should the wire be? Okay? How long should the wire be? So remember, this was my wire. Okay? That was my wire right there. So that's the length I'm trying to find. That's my goal. Okay? Well, let's look and see what we have. If that's 10, this is also 10. Sine, cosine, tangent coming into play. Here we go. Always start at my angle. I'm always starting at my angle with sine, cosine, tangent when I'm trying to find a missing side. Okay? So I'm trying to find a missing side and I have an angle. Triggers me to use sine, cosine, or tangent. Again, I have one side. I have an angle. I'm trying to find another. Triggers me to use sine, cosine, or tangent. Now that I know I'm using sine, cosine, or tangent, I'm comparing it to the angle. I started my angle. I've got 22 degrees here. Okay? I've got 22 degrees. Okay? What is this? That is my opposite side. What is this? That is my hypotenuse. We're using SOHCAHTOA. We're using my acronym that we can always remember. Hopefully we can remember that, and then you don't have to think so much in your brain. Okay, so we got O and H. O and H right here, that uses sine. So it's sine of 22 degrees equals 10 over x. That's a two-stepper because x is on the bottom. I swing over x, so it's x times sine of 22 degrees equals 10. I swing over that, so it's x is equal to 10 over sine of 22 degrees. Again, I multiplied by x from here to here, and then I divided by sine of 22 from here to here. So I end up with 10 over sine of 22. Maybe let's zoom in so we can see it a little better. Okay, and then got to make sure I'm in degrees mode. Oh boy, my calculator's too big now. I am in degrees mode. I clicked mode. Yeah, let's zoom out. Attack of the mega calculator. There we go. Okay. And so we've got 10 over sine of 22. Okay, so 10 over sine of 22. I was in degrees mode, so I was good to go. And there we go, 26.7. Okay, 26.7 is what my wire length should be. Okay, so if you're trying to connect, top of the building, and all you had was the angle of depression here, which we converted it to an angle of elevation. We've now got the picture, and we drew everything, and we end up with 26.7 degrees. Sorry, 26.7 meters. It's in meters because this is a side length. That's how long the wire should be. Cool. Alrighty, next one. Okay, find the angle of elevation to the sun when a 12.5 meter tall telephone pole casts an 18 meter long shadow. Cool. Okay, 12.5 tall, 18 long shadow. Here's the sun. Right? It's the shadow. If you want to, boy, that's the best shadow I got right there, I guess. There's my shadow. Here's the telephone pole. I don't know what do those things look like. Look like that. We'll go with that. There's the telephone pole. I'm a pure artist, so this is pure art in the flesh. I'm just getting distracted now. Okay, right angle. Okay, you got 12.5 meter tall telephone pole, 18 long shadow. Here's the sun. Okay, we're asked to find the angle of elevation to the sun. So angle of elevation. Okay, maybe we draw a quick horizontal line. Okay, we've got the horizontal line, and it's opening up. So that's what it's going to look like, or it could look like that too. Either way, right, left or right. That's the angle I'm trying to find. Let's go ahead and call it theta. Okay, theta is the angle. Okay, so with theta, all right, I see that I'm trying to find an angle and I have the sides. Again, that triggers me to use trigonometry, okay? Compared to the angle, always compared to the angle. I've got this as my opposite. I've got this as my adjacent. No hypotenuse, not in the context of this problem. I've got sine, cosine, tangent. Okay, so compared to theta, opposite and adjacent, so it's tangent of theta is equal to 12.5 over 18. That should ring a bell, right? I'm trying to find the angle. If I'm trying to find the angle, that's when I'm going to use my inverse. So tan inverse of tangent of theta, and then tan inverse of 12.5 over 18. Okay? That's what I'm going to put into the calculator. That right there. Okay, so I've got to make sure I'm in degrees mode. There it is. And second tangent inverse, 12.5 over 18. There it is. We've got 34.7 degrees. Cool. There's that one. Biggest part is getting a picture from the words. Okay, I will say. So you got to be very diligent there. Make sure you draw the picture correctly. Sometimes you'll be given a picture, sometimes you won't. From the top of a 120-foot tower. Boom. I'm just going to, start there. Okay? An air traffic control observes an airplane on the runway at an angle of depression of 19. How far from the base of the tower is the airplane? All right. So, here's the airplane. Kind of looks more of like a shark. I don't know. There's my airplane on the ground. Okay, it is on the ground. Here's the control tower. Okay, and they see it at an angle of depression of 19 degrees. Again, they're at the top of the tower. They see it at an angle of depression of 19 degrees. So, gotta have my horizontal line of sight. Remember, angle of depression, always from the horizontal down. It's not in here. It's from the horizontal down. So this is my 19. That angle. I can move that 19 over here, gives parallel lines and alternate interior angles. So there it is. And I'm trying to find how far from the base of the tower is the airplane. So there it is. Okay. I don't even need that 19 up there anymore, but I do see this 19, and that's useful. Okay, so I've got 19, 120, right? I'm using trigonometry here. Okay, I'm circling that 19, so I got it right there. This is my opposite. This is my adjacent. So I'm going to use tangent. All right, so tangent of 19, always tangent, sine, or cosine of the angle. Tangent of 19 here is equal to 120 over x. We've got to think about this. If this is a two-step or a one-step, this is a two-step. I swing over x. X times tangent of 19 equals 120. Last step, I divide. So I've got 120 divided by tangent of 19. I can put that into the calculator and get my face out of the way. So we've got 120 divided by tangent of 19. There it is. So 348.5 feet away. Uh-oh. 348.5. Okay. That is my last angle of elevation and depression problem. Again, be careful with the two steps. Be careful with the angle of elevation. Remember, I think most people are pretty good with the angle of elevation, right? They see the horizontal line, they see it's going up. When they see that angle of depression, they're very tempted to put in here. Remember, it's from the horizontal down, okay? Make sure you're setting up your trig correctly, okay? And just to kind of recap our steps, so we set it up here. We multiply both sides by x from here to here, and then from here to here, we divided both sides by tangent of 19, so we were good to go. All right, that is it. for angles of elevation and depression.